This conference will now be recorded.
Sorry, I forgot to do that earlier.
No worries. All right. Good afternoon, everybody. As I said in the introduction, I'm Marcus. I'm the program scientist for the estuary program. I actually talked to this group earlier this year, I think at the spring meeting, kind of giving an overview of the tools that we've developed to basically operationalize the Habitat Master Plan update that has sort of been our founding document for this group. It's a great document if you haven't read it. I hope that most people on the call are familiar with that document. But it's one thing to kind of create a method and a report. It's another thing to sort of operationalize that in different ways. And I think that's a theme that we want to emphasize through our talks today, both mine and Gary's, is how do we take the data that can be used to inform these decisions of what is a priority site to acquire, for example. So I'll be talking a little bit about that. One, what is this process of operationalizing the HMPU, but also talking about what are some of the recent results we've got from some of these updates to the data layers that feed this process for building the assessments of the different goals that we have for the targets. So my goal for today is a couple different things. I want everybody to just, again, understand and appreciate what the HMPU is trying to do. So I'll revisit that in a few slides. I spent a lot of time talking about that when I spoke to this group last time, but I think it's important to remember what this document is trying to do and how we can use that as a template for moving forward to identify different restoration or enhancement opportunities. And then I'll talk a little bit about this, what I'm calling a reproducible workflow to operationalize the Habitat Master Plan. And this is a multifaceted problem that, again, is not really solved at this point, but we're, I think, making steps to operationalizing it. And so I'll talk about one way to do this. Again, Gary will hit on some of those topics as well, and hopefully we can have a conversation around those issues towards the end. But then I want to present some of the results of what we've seen with the update of the acreages for our different categories under the HMPU for different restoration targets. The HMPU document was built on a lot of spatial data. And when it was developed, it used some layers that were all sort of publicly available data sets. But these are data sets that get periodically updated over time as managed mostly from the Water Management District as well as other places. But one of the major data sets is the land use land cover layer. And the one that was sort of feeding the status and trends report in the HMPU was the 2017 layer. And we've just seen an update to the 2020 layer. So I want to report on how we've taken that new data set and updated the numbers on how many acreages we have in the different categories. And I'll also do the same for the subtitle layers that are provided by the district. So the Seagrass layer that was just released earlier this year, the 2020 layer, seeing how that changes our assessment of status and trends. And also layers coming from the Florida Natural Areas Inventory. They feed a lot of the updates on what areas have been or proposed for conservation, and those are actually updated every 3 months. And so we've rolled in those new data sets with this new update to the district layers to sort of see how these trends are working for us with this new update. So to kind of revisit the HMPU and what it's all about, apologies, you've probably seen these types of slides a bunch of times so far, but again, as I said, I think it's useful to think about what this document is trying to do. Prior to this update, this HMPU update that we had last year, the paradigm that we were using at the estuary program to prioritize restoration was basically built around this concept called restoring the balance. And that was used for a long time, very successful, but really kind of focused on ratios of different habitat types. And we thought with this most recent update of the HMPU, we need to revisit this core paradigm of how we think about targeting and prioritizing areas for conservation and restoration. And that new paradigm is maximizing the potential. So basically identifying not only what the trends have been in the past for these different categories, but where we can look moving forward of what are these priority areas to conserve. And that's a little bit different from the old paradigm because it's a retrospective look at what has happened, but it's also a prospective look moving forward, keeping in mind that there's different stressors acting on what could be driving land use change. There's sea level rise as another stressor. So we wanted to take those things into account when we look at where do we prioritize different restoration activities. So that's the main paradigm, and it does again sort of represent this shift towards a different way of thinking about how we prioritize different activities. Some of the key things we got out of this document were basically summary tables that really gave us this high-level overview of these big questions of how much of these different habitats do we have, and how far are we trying to go looking out in the future for what are our targets of what we want to conserve moving forward, knowing what's happening with these the trends of land use change over time. And so this is one of the main tables showing us our current extent and the different habitat types. This is actually missing the subtitle component, or actually the uplands component. But we have the categories broken down into different strata. We have the current extents here, and then we have a 2030 goal, what we think we can achieve, and then a more longer term goal of 2050 targets. And so this is what we should always be referencing when we think about where we're going in terms of what we want to protect and conserve in the Tampa Bay watershed. And another thing that distinguished the HMPU from the previous habitat master plans that we had was there's a heavy emphasis on spatial data. And this part is really cool because you can actually take any of these maps and sort of drill down and identify where these existing opportunity layers are in terms of what's already conserved, what's proposed for conservation, what we want to reserve in the nearshore environment, as a way to sort of guide actions of where we could target the different projects. And another map that I think is really useful is this restoration potential map that sort of lays out of these areas that are proposed for conservation or could be put into conservation, what are different restoration categories you could shoot for that takes into account the soil types, the elevation, that sort of thing, to think about what would be a reasonable habitat to shoot for and how to build towards building the numbers in that table that I just showed. So again, this spatial component I think is a really important aspect of it. So this whole document was a nice way to lay the framework for what we want to do. And as I said before, when we had this document, we said, okay, now we have a plan, but we need to operationalize it. The first challenge being that we know the source data that feeds these assessments, the status and trends tables, are updated periodically, and it's not a simple process to go from the source layer to that table. There's a bunch of steps in between, and we wanted to make sure that we as a program, once we had the document handed off to us, we could reproduce those numbers so that we can, say, every year come back to this group and give you guys an update on how well we're doing in achieving these different targets and goals. So we wanted to figure out that process, first of all, operationalize it, but also produce the results in a way that was spatially explicit, knowing that the maps are a really important component of this whole plan, and also giving the summaries in a context that's important for our partners. So we wanted to break down not just the watershed level summary, but break down the summaries by different jurisdictions that we work with. So municipal boundaries, county boundaries, that sort of thing. And we wanted to do this as quickly as possible because when the data come out there, when new data are produced, we wanted to basically just say, let's drop it into this workflow and update the tables as fast as we can because we want this information to be timely for our partners. So the talk I gave earlier this year was really about that whole process of how do we operationalize this. So I don't want to go into that, but basically a lot of coding and data analysis. But what we ended up with was a way to update these results as new data came in. And I'm going to actually jump to the web page we have on our main website for the HMPU, just to show you what some of those products look like, so you can kind of be reminded that they're out there, they're available for you to review and understand, and how to use them for informing restoration projects. So if you go to tbep.org, Habitat Master Plan Update, there's a whole lot of great stuff here, links to the main document, links to our target setting approach. But if you scroll down, there's this section here that is actually a way to access some of these tables and spatial data layers that provides the results in this high-level summary of the whole watershed, as well as by different municipalities. So if you click on this map, you can see the summaries by different boundaries, as I said. So these are our main partners we're going to be working with. So we wanted to serve up the data relative to their jurisdictional boundaries, just to show you what that looks like. You can click the map for any one of these and see, the breakdown of this opportunity map layer by, the city of Tampa boundaries there. So that's all well and good. Same thing for the restoration potential. So if you wanted to target different areas for restoration in your particular area of interest, you could pull up this map and see that, oh, this would be a good place to target coastal uplands, for example, down there. So that was the whole idea behind that. And what's super cool about this is that all of these data layers are fed by all of these data sets, rather, or the maps and tables are fed by the most current data sets we have available. So as I said at the beginning of this talk, we have now an updated 2020 land use land cover layer. We have an updated seagrass layer. We have updated conservation layers. Those are now fed through this whole process, and the tables you see now, the maps you see here on this website, are using the most current information. So the numbers you see are going to be different than what's in the original HMPU document that was published last year, because we have new information. So that's available. Another cool product we created that I think is helpful for understanding this bigger question about what's happening in our watershed, these high-level trends in land use change, is our land use change dashboard here. And this is fed by the same data layers that go into these tables and maps, but breaking it down by broad categories of the different habitat types that are in the HMPU. And so if you go to that dashboard, you can see this summary here. Basically, you can scroll through the different years and see how land use has changed over time. Now, again, a lot of these trends have been summarized in the HMPU, but this is great because it puts it in a more interactive context, but it also is updated with the most current data sets we have. So if I wanted to look at, for example, the change from the 2017 land use land cover layer to the 2020 layer that we now have available, I can move the slider here. I'm actually going to zoom this in and see a summary of how those results have changed between these two year pairs. So coastal uplands up 65 acres, developed land up 15,000 acres. So you can kind of get a sense of what has changed in those 3 years. And I'll go in a little more detail what these results, what we think they mean in a second, but I just want you to be aware that this is a product we have at your disposal to help you understand what these changes are. We've done the same thing for the subtitle layers, so the seagrass layer that we get from the district. So this is in its separate tab because this is a data set that is released not always at the same time as the land use land cover layer. And so it's hard to match those things up in time exactly. So it's on its own separate tab with its own year categories based on when those different data sets came out. So you can do the same thing there, look at how the different year pairs have changed and so on. So that's all available. I again just want people to know that it's a resource you can use. We try to keep it updated as best as possible as the new data sets come online. But please have a look at those and hopefully try to get a sense of what's going on with the different trends. So what is going on with the different trends? Now, I wanted to also spend some time today talking about what we saw now that we've updated the results from the HMPU with these new data sets. And this is fairly high level. It looks at just land use land cover changes It doesn't necessarily get to the scale of individual projects. That's something that Gary will talk about, and I think there is some kind of conflict between how we mesh those two different sources of information, these high-level GIS layers with project-specific data sets or databases that describe what happens at the individual project level. And we need to have that conversation. But for now, what I'm going to show you is just what's happened with this simple data update. So this is the Uplands or the coastal intertidal summary that I just showed you from the dashboard. Basically, if you remember from the original HMPU document, you know, there's individual trends going on with any of these different categories, but the overwhelming trend I think that we've seen so far to date, going from like 1990 to present day, is a huge increase of development and loss of upland habitats. If you scroll the slider for the year pairs to the 1990 and most current, you can see those changes as being very dramatic. If you look at the 2017 layer versus the 2020 layer, I think that's sort of the same trend, just at a much smaller time scale. So as I just showed you, there's a huge increase in the developed lands, which is no surprise. But some of these other layers, you know, the coastal uplands, native uplands, there's some change there. We're still kind of losing native uplands. Intertidal habitats are changing as well. But again, it's this increase in developed lands that's a concern. The other major concern is this loss of restorable lands. And this is sort of a category of lands that we think that, you know, if they were to be acquired and there's effort put into the restoration or enhancement of these lands, they could turn into native habitats over time. But basically, these opportunities are being lost. Even in these 3 years, we've lost about 17,000 acres of these restorable lands. And that reflects a broader trend we saw from 1990 to 2017 in the original HMPU, but it's still happening in this 3-year time frame. So I think that's important to recognize. Is development still continues, restoration opportunities are declining.
Hey, Marcus, could you go back to full screen if you're not going to be popping back?
Yeah, sorry. Yeah, so looking at the uplands and the intertidal habitats, basically what I just said, development's increasing, restoration opportunities are being lost, and we do see some subtle changes with these other habitats, upland habitat loss as well, which is of course a concern. I do want to point out this graphic too. If you go back to the land use dashboard, there's other tabs that will show you basically this proper change analysis for different year pairs of where the different land use categories were in 1 year and where they went to the next year. And so what this is showing you basically is this is a breakdown of total acreage in 2017, and this is the acreage in 2020 by the same categories. You can see which category went to which other category between 2017 and 2020. And so obviously development in the uplands is the biggest category. It did increase a bit, but what you can see here is that this restorable chunk, there's a good old slice going over to the developed lands, and that's that 15 or 16,000 acres that I just mentioned. So that's a trend that is still continuing, that we have seen for the entire record of data that we have, that is still being exhibited in this 3-year comparison. Also on the dashboard, we have this table that kind of shows the same breakdown that you see in that graph, but in tabular format. And so what you're looking at here is just the same thing, but in tabular format. We have the sums for the 2017 totals for the upland habitats and intertidal habitats, and then the sums for the 2020 habitats on the bottom in the columns here. If you go on the app, this table is scrollable, so this is why you only see 3 categories here, but you can actually move them left to right on the app. But I just wanted to show you here that, you know, here's down here the 2020 total acreage of developed habitat. And what these categories here show you is, of the 2017 categories, what went into the 2020 total for developed. And so looking at this again, most of what was transferred to development in 2020 was restorable habitats. So 15,000 acres there. So again, just want to drive that point home that we're continuing to lose opportunities where we could pursue restoration projects.
Hey, Marcus?
Yes, sir.
Doug Robeson. I'm sorry to interrupt. I just want to clarify that the term restorable, if you go back to the plan, refers to what we call soft development, which would be things like ag fields, golf courses, fallow land, empty lots, that sort of thing, as opposed to hard development, where there's actually paving and ERP, anything that with an ERP would likely be considered developed. So when you're talking about losing restorable properties, you're talking probably the loss of ag lands and that kind of cleared but not fully developed land.
That's correct, and that's a very good point. This isn't like pristine native habitat that we're losing. We are losing some of that, but it's the opportunities where we could turn it into, I think, native habitat that we're losing, and it's these areas that are not necessarily, like you said, hard developed, but could be restored in a way.
Marcus, I got a question for you. What's your definition of a coastal upland? Is that like uplands within a certain distance of the shoreline or something?
Yeah, I forget the exact definition, and Doug can clarify this, but it's the same thing as upland, native uplands up in the watershed, but it's within the coastal fringe, right around the edge of the bay.
Who's anything within the below the 5-foot contour?
Yeah, and that was decided as a separate category in the HMPU because that's an area that's more susceptible to sea level rise, obviously.
Thank you.
All right. So moving on to subtidal habitat. Again, you could look at this on the dashboard. I don't think this is going to come to a huge surprise to everybody if you've been hearing any of the presentations over the last year, but we've lost basically a ton of seagrasses in Tampa Bay from 2018 to 2020, about 6,000 acres, according to this table. Just want to point out, there are some discrepancies in the numbers that you see in the dashboard between what, say, the district or some of our more formal reporting products are providing, and that's due to different boundaries that are used in the HMPU versus other boundaries that are used for reporting. But the overall picture is generally the same. We've lost a lot of seagrasses, and that, of course, is a concern. And that is something that has been happening in Tampa Bay as well as regionally. We know that Tampa Bay does have its own set of unique issues that we need to think about. But if you look at the Southwest Florida area as a whole, there's been seagrass loss across the entire Southwest coast in general, and that could be due to large macro scale factors like climate change, for example, sort of to be determined what's really driving those changes. Going back to the app, you can again see where seagrasses went, what categories it went from 2018 to 2020. This is the 2018 bar. This is the 2020 bar, so a little bit smaller. But according to this plot, you can see that, well, basically a lot of it went to open water category. That would probably be the deeper edge that's doing that. And also a lot of it went to tidal flats. So we actually gained some acreages in tidal flats according to the 2020 layer, which may or may not be a good thing. We do have targets for that category, but we've lost seagrasses as a trade-off for that. I also want to point out that, in case it's not painfully obvious, I make a lot of dashboards. We have another one for reporting on seagrass trends over time. You can actually look at this one to do a more detailed spatial comparison of changes over time in the seagrass layer for Tampa Bay. This is just showing you kind of the breakdown of acreages gained or lost by what we're calling our seagrass management areas. And these are things that we defined as a program a while ago to sort of guide management activities towards different parts of the bay that had their own kind of characterizations. But what we see here is that most of the seagrasses we lost in the bay were in Old Tampa Bay. We kind of have a good sense of maybe what's driving that. But it was this Feather Sound region that is, it can be quite volatile over the years, where we saw a lot of loss. But if you do have an interest, feel free to check out that dashboard to get a sense of the trends with seagrasses specifically. So I wanted to close my last couple of slides doing a side-by-side comparison of the tables that we had in the original Habitat Master Plan versus what the numbers look like now with this update to the data layers, with the 2020 land use land cover, the 2020 seagrass, and then the update to the conservation layers from the Florida Forever website. So this is looking at subtidal first. I'm going to go by the coastal strata, so subtidal, intertidal, and supertidal, going through those three different stratum. But you can see here that in the original HMPU assessment, we're actually doing pretty good. In subtidal, there's a big emphasis on oyster bars. You know, we need to continue restoration there, obviously. But again, looking at what we saw with the update to the seagrasses with the 2020 layer, we're actually below our target now, which is of course a concern. And we as a program care a lot about that, and we're pursuing many research and management activities to try to understand and pursue options to try to improve that situation. But that's the main story here for subtidal. Other layers like hard bottom and artificial reefs, these aren't actually included in the data sets from the district, and there's sort of a separate process that can be used to update those layers that is going to this bigger problem of how do we routinely update layers that aren't part of a standard process that's sort of curated by a large institution. And we could talk about that later, but we don't really have a good sense of what's going on with these two at this point. But we're generally doing good based on the original HMPU assessment for these categories. Moving to the intertidal habitat, again, living shorelines, this is another one of those layers, as well as tidal tributaries, where we need to think about a better way to update those layers, because there's not information with those layers included in the district's data. Could be part of a restoration database that Gary will talk about, but again, how do you mesh those two sources of information? But what you can see here is that, you know, we did actually see an increase in intertidal habitat. It's not a heck of a whole lot. I mean, we're increasing by a couple hundred acres in some cases. And again, this is just the 2020 update. I know as Gary is going to report, there's other projects in the 2021 database from the restoration projects that are being tracked that can provide alternative assessments of how these updates have occurred. But generally, according to these layers, we're doing quite good with intertidal habitat. And then the uplands, we already talked a lot about this. This is, you know, the big concern of increasing development and loss of restoration opportunities. And so you see that in the original HMPU document, we didn't meet any of our targets for 2030. Here it looks like we may have had some improvements looking at just the 2020 layer. But these are pretty minor. So, you know, non-forested wetlands, 67.5 thousand acres. Now we're showing 69.5. You know, that's you know, percentage or two increase. We've lost forested freshwater wetlands. You know, and so there's general questions about what these numbers actually mean in the context of loss of restoration lands, and as well as the ability of these GIS layers to actually differentiate these different habitats that we can talk about later if we want to get into that. So just to summarize, bring it home, you know, I think we have made a lot of progress. You know, we've held the line in a lot of cases in the last 3 years based on looking at this new data set, but we've also had some losses. Obviously, seagrasses is a concern that I said we're still thinking, always going to think about as a program. Oysters, I know for subtidal habitats, we need to keep working on that. I just wanted to bring to everyone's attention as well that we do have this habitat suitability index for oysters. That's basically a map that shows you areas that could be targeted for restoration as a way to you know, if you wanted to put in some oyster beds, what would be the best place to do that? And this map could point you in that right direction. So that is available as a resource for people to use if they want to think about oyster restoration. Intertidal habitats, we seem to be doing okay with the tidal marshes, the mangroves, the juncus, but also Gary's going to talk a little bit about that. And I think, again, that goes back to challenges of rectifying, what these high-level GIS spatial data sets say versus what we're actually tracking in different restoration databases, and how do you marry those two sources of information. And then uplands, of course, the diminishing opportunities with the loss of restoration lands, or restorable lands rather, that I think we always need to be aware of. So definitely have a look at the website. The jurisdictional specific summaries by county and city are available. We also have shape files for those opportunity maps and those restoration potential maps that are available on request. I've only had 2 people email me for those shape files in the last year. So I don't think they're getting used as much as they could be in terms of identifying where these priority areas could be. But we do have them available if you want to actually, look at the parcel level of where you could acquire different lands. So just let us know if you want to get hold of those. And then, yeah, this bigger question of, multiple sources of data. How do you, combine progress and assessment of different lines of evidence in a more coherent fashion. So, and Gary's going to talk a little bit about that. So that was my talk. As usual, I probably talk too much, but if there are any questions about any of this, I'd be happy to chat some more. Thanks.
Thank you, Marcus. Does anybody have any questions or anything that they want to bring up at the moment? Going once, going twice. I expect basically everybody to contact Marcus for those maps and shape files, and then come to me for project ideas for CFI. So let's get to it. I think there's a lot of opportunity out there, and we definitely don't want to miss any of those options. Gary, it looks like it's going to be your turn.
Thank you. And I got one question I can't remember from our discussions, Marcus. For your salt marshes, did you divide those between the isohaline areas, or were you just using the district's salt marsh flux code?
They should have been divided. When we went through the process of creating these tables and reproducing the numbers that we saw in the original HMPU document, we tried to follow their methods exactly. So the salt marshes are the juncus habitats, and that includes also a salinity layer to parcel up the flux code from the district. And so that should have been reflected in there.
Okay. Very cool.
All right.
I will. There you go. Definitely thank you, Marcus, for setting that up. You're not going to hear the explanation of the Habitat Master Plan target and goal setting process from me again, because he hit it spot on what we're looking to do with this. And the work that I'm going to talk about from 2021, the federal fiscal year for October, so October 20 to September 2021. And so this is basically the year after Marcus finished his reports. There's no connectivity that way. The restoration that's here does not reflect that 2020 LULC data. This will be seen, hopefully, and this is part of the discussion we need to have. This will be seen in, hopefully there'll be a 2023 LULC, and we'll be able to look at the next 3 years. But what I'm going to discuss here is habitat restoration that's been reported to the estuary program for the past year. And we do this as part of what's called the Government Performance Results Act. It's a report we send to EPA every summer, projecting the habitat restoration that you, our partners, do over that year, and then we put it into a database, and they review it. We have some conversations and get that reviewed. And now we're going to be able to use this as our tracking mechanism for progress towards those habitat restoration targets in the 2030 tables that Marcus was sharing. So now I'm going to talk about what has been happening in the system. And first, I'll share some of the results from the 2021 restoration data. Try to relate this to the Habitat Master Plan targets that have been established, how we're doing in these different components. There are some habitats, I think it'll become fairly clear that from this single year of data, and that's one of the important take-home messages, is this is only the first year of a 10-year tracking process. How there are some habitats that didn't receive focus, and we may need to make sure we're thinking about that going forward. And then I'll talk a little bit about some internal thoughts we've had about a new reporting process Marcus mentioned, to try to do this on an annual basis in a more formalized format. And then I'm going to give you all a couple of project highlights that were shared by several of our different partners. So from FY 2021, the projects that we received information on, there was a total of 70 projects, a little over 800 acres of habitat restoration. And the breakdown is between habitat restoration, and that's physical work such as earth moving or initial revegetation. It can include exotics removal plus native plant installation. And the same thing with miles restored. That's either living shorelines or our tidal tributaries, which were two of the habitat focus areas that we have. And then there's this idea of enhanced that goes into our annual report to the EPA as well. And that includes prescribed burns, maintenance for exotics removal, other projects that actually have occurred on a footprint we've already reported. So at Hillsborough County, if they're doing exotics work at Cockroach Bay, a lot of that is enhancement because it's already been reported as restored. We're not restoring it over and over. We don't want to do any sort of double counting. And so there were nearly 30,000 acres of enhancement. So it's, our partners are doing an awful lot of work out there, and you absolutely know this. The land management efforts that are going on are extremely impressive. And then 13 miles of enhancement along our tributaries for a total acre impact that we've had reported of about a little over 30,000 acres and 13 miles of restoration and enhancement. So to start breaking this down, there's two slides that are like this. The blue area, the top of the blue area represents the target for 2030 within the Habitat Master Plan. And so these are the habitats with slightly lower overall targets. And then the green areas represent what habitat restoration was reported in 2021. So you can see in the coastal uplands, we had about 35 acres. Forested freshwater wetlands, there was quite a lot, nearly 147. We're hitting the mark for the established target pretty close just during this first year, and that was mostly due to work in the lower green swamp. So doing some ditch blocking, altering the hydrology in there, restoring some function. I will say there's a little bit of oyster bar that was hidden. It was about, I think it was on the order of less than 1/10 of an acre of habitat restoration at oyster bars at Whiskey Stump, and I'll talk about that a little bit later. But so this starts to give you this picture of some of the habitats that we have identified and we are tracking for restoration projects. And then these habitats, it's a different scale, so I put them on a different slide. Again, the same format. Estuarine intertidal systems. This is a catch-all that does not include those low salinity marsh habitats or salterns. So this is mangrove habitat or any mix that includes those intertidal systems. The 10-year target was 1,000 acres, and we reported, I believe it was about 150 acres of habitat restoration during the FY 2021, and that was from one of the phases of Robinson Preserve. And then for the non-forested freshwater wetlands, slightly over 200 acres, Again, that was Laurel Green Swamp and a project out in Lakeland. And this shows you that relative to the 1350 over the decade that we're planning to, that we have as a target for that project, for that habitat. And then our non-coastal uplands, again, this is the area of uplands that are above that 5-foot contour. We reported about 200 acres that was restored, and it's I believe it's about 450 was the target for the 10 years. So it looks like we're doing fairly well on that at this moment. This is recreating those two slides, but on a percentage scale. So they're all at the same level. This shows you, for instance, for the estuarine intertidal, about 15%, we hit about 15% of the 10-year goal within that, within the first year. And again, we're very close to the entire goal for forested freshwater wetlands during that same 1 year because of one large project that came in. One thing we do recognize is that these projects aren't going to be consistent. It's non-linear. There'll be lean years, there will be fat years when we get a lot of habitat restoration projects reported in one habitat, for instance. And one of the definite ones about this is oyster bars. I know Manatee County is working on a long-term plan that won't be completed until, I believe, at least 2027, 2029. And so it sort of at the end of the year, at the end of the decade, as long as we keep working with them and pushing those plans along, this may start to creep up, but then at the end of the decade, there'll be a larger shift. So we need to use this in a couple of different ways to make sure that we're focused on specific different habitats, but also to know how we're moving along in the overall process. And so this is my initial take on some of the habitats that we didn't see any progress on, or very little progress on in this first year. And like I just said, this is only a 1-year snapshot. We can expect these things to cycle through and over. For instance, oysters, we have a 50-year target to 2030, and there was about 0.2 of an acre that was reported restored. Nothing was reported as restored in low salinity salt marshes or salt barrens or the tidal tributaries. And a very short mileage of 0.03 miles of living shorelines was reported within the FY 2021. And the living shorelines is a good example because last year from the FY 20 restoration report, I think it was about 1.3 miles of living shorelines that was reported, from several projects that were conducted in the Hillsborough River and elsewhere. So again, these things are going to be somewhat sporadic, but we want to make sure we're still keeping the pedal down. We want to make sure that we're recognizing where we might be falling short. And that's where this idea of the annual report card is coming in. And we've had some very brief conversations inside the office, potentially something similar to the annual water quality report card that shows chlorophyll and light attenuation, and then brings in the seagrass data. And then in the vision that we have right now, we talk about these annual restoration targets and accomplishments there. The most recent land use, land cover, and seagrass data as provided by SwiftMud, be able to mesh those in. If there have been updates to our hard bottom or artificial reefs or some of these other categories, we can include that as well as parts of this discussion. See if there's some of those the flow charts, whether or not we need to, when we need to have that recognition that there are important management steps that we need to encourage throughout our partnerships. Identify those needs and those successes that have been occurring on the habitat restoration side, and how that fits into the overall land use analysis that's going on. And then also trying to understand how best to share this with our partners, whether those are the land managers or the policymakers or the general public that is interested in what is happening within these systems. And I'll stop there real quick and see if there's any discussion.
I got a question for you.
Mm-hmm.
So you stated that 811 acres were restored. About half of that, 250 acres, were salt marshes and 150 acres were uplands. Are these realistic numbers? I mean, do you think this is accurate? These are actual restoration acreages. That's a lot of acres. And who's doing it?
The database has the that I'll be talking about in a moment, does have all of that, has the partner information in it. It has the cost. One of the shortcomings of this report that we recognize, and we do need to figure out if there's a way to crack that nut, is that when we get reports of habitat restoration, if there are 3 different habitats that are in a single project, say rock ponds, you know, we get one data point for acreage for all of that habitat, and it just goes in like that. And we recognize that there needs to be a better way to report that. I'm fairly confident that we're getting a good footprint on these, but again, I will say that I don't think the habitat breakdown is accurate.
You know, and my only concern is that we just are creating false reality. We're reporting, you know, acres that don't really exist. I know decades ago, I saw the Coastal America program do exactly that. And it sounds good and it looks good on paper. For example, we got a grant from them for a Cockroach Bay project. We used their money to do about a 65-acre project. But when they reported it, they reported the whole Cockroach Bay site and said that 500 acres were restored. That's just not accurate. You know, it's just not correct. So I would just hope that we would always be honest with ourselves and report what is drop dead, the actual numbers. So nobody is like a false sense of security, like, oh yeah, look, we're doing a great job. Well, it needs to be based on truth. So I'm just broaching the topic. That's a lot of acres, and we've had a lot of COVID and a lot of stuff not, you know, maybe not getting done. So I just was curious where it all came from. So.
And those are great points, Bryant. You know, as Gary mentioned, we're having that internal dialogue of, you know, what this restoration database means in light of some of the land use, land cover information that we receive from the district, and what are the timeframes that these restoration activities sort of manifest in that roll up into a broader spatial data set. And as we report on progress, you know, we have to decide, I think, as a consortium, what is realistic in terms of our progress of this 10-year period, and how is it reflected in the available data sets that we have at our disposal to report on that progress. And we definitely don't want to inflate numbers based on you know, data discrepancies that we recognize in some of these data sets. So that's why we want to have this discussion with the consortium and work through a process that is analogous to the water quality report card that we use to guide our future management activities. But we really need that input from the consortium to help us shape what that report card would look like.
And we do make a very concerted effort when we're getting the data back from our partners to let them know that we only want the actual area that is impacted during that project. I mean, for instance, from this one, Robinson Preserve, it was 150 acres that had never been reported on within GIPRA that went into this report. And when you know, when for rock ponds, I think it came in like 4 phases to us, the different data of different sets of data. And so we're definitely going back and looking at at previous projects in the same area and making sure that the data makes sense, and we're not double counting. It's definitely something we're very cognizant of.
Okay, thank you.
Gary and Marcus, you know, I think I've mentioned to Gary that the district has been working diligently on compiling all of their projects for SWIM, and we've been looking at actually creating shape files based on the very specific different types of restoration that was done or creation. When you're receiving data from folks, are you asking for shape files so you can be kind of double checking and making sure people aren't doing this double dipping, or you're just getting a point and an acre number?
We're just getting a point and the acre number. I mean, definitely getting that the as-built or some sort of shape file would be a gold standard that we could discuss going towards, but there would be another, you know, I don't know what the effort would be by some of our partners to get that information to us, but I would love, you know, that's one of the conversations that we've also had in the office, is that would be amazing if we could get that level of detail for these. And then what that would do, you know, for looking at the 2021, 22, 23, and then do restoration data, and then taking the 2020 land cover and comparing it with the 2023 land use cover when that comes out, and then being able to collapse those 3 years of data into that and see what our results are.
Sure. I mean, speaking from the districts, you know, in SWIM, we've been making it a deliverable and a requirement, you know, at least for the last couple of years, that our cooperators and consultants are delivering that detailed shapefile to us. I'm wondering if any of the other cooperators online, you know, are going that route, and how difficult they think that would be to get that information to TBEP.
Yeah, I think last time I talked about this, I made a plea to provide shape files if possible, but I understand there might be like logistical challenges of, you know, not just like from the technical side, but you might not even know like what the boundaries are exactly. But I would just encourage that, and you know, we can manage shape files as they come in or as needed, or figure out a process to figure that out, because a point estimate is not going to be the best idea or way to capture the actual effort that's happened on the ground. But I still think the bigger challenge, and Ed alluded to this, is that, you know, the hope is that with these projects accruing over time every year, being entered into this database that Gary's talking about, the hope is that they will be manifested in these large GIS layers over time. But we don't know what a reasonable time frame is for that to happen. I mean, there's minimum mapping units for these layers that apply, but we also don't know if the methods used can capture some of these smaller scale projects. And so it's necessary to track them at the scale that Gary's talking about, but we don't have a good way to marry just sort of this spreadsheet style of here's where it is, here's how many acres, here's the type, versus the large spatial data sets that we're using to drive these tables. And that's the bigger question. And I think that's where it's kind of a research question, kind of not, but it's more of an operationalizing question that we'll need to figure out over time.
But Jamie,
Yes.
I agree that the district's approach, and I'm hoping to hear presentation on that database sometime soon. But that's definitely something I'd be interested in shooting for. And you know, it occurs to me I can at least put that in the email that I send out middle of the summer when I'm asking for this data, to send along those shape files if they have them.
Yeah, I mean, certainly asking, you know, at least gets people thinking, and hopefully this gets people thinking. And yeah, we'll see what happens, and definitely looking forward to as well to being able to share what the district's been doing. So that should be forthcoming.
Also, I guess it occurs to me, you know, of course, quite a lot of the projects that we have are at least partially funded by the district, so they may be already sending you some of the shape files. So I don't know, for those, if you could act as a clearinghouse.
Yeah, and that's certainly a possibility. I know we had been talking internally, trying to decide what type of projects to be including. in our database. I know initially the original intent, we were just going to be including district initiative projects. There was some discussion as to whether or not we should be including our cooperatively funded projects, which would then, yeah, I mean, we definitely have to make sure that we're not aiding in your double dipping. But yeah, I mean, at that rate, then we could also potentially be helpful. I'll be honest, I'm not exactly sure where we have landed on that decision. So that's something I could help follow up with. And Gary, I know you've been talking with Tara and our Mark. And so hopefully they've been providing some insight there for you.
Hey, Gary, this is Brandon Johnson. Can you hear me?
Yes, you can, Brandon.
Just a quick question, kind of on this discussion of the accounting, so to say, and there's concern of double dipping and accounting for whole project areas versus acreage that were actually restored. But I'm wondering how you all are looking at these projects kind of on the opposite end of that. Certainly, we all recognize that the benefit from an acre of restoration isn't equal to the area, to that size. So what comes to mind is placement of some of these projects adjacent to prior restoration or gaps in connectivity. So I know I totally understand the concern of extrapolating or expanding or double dipping or whatever you want to call it, and inflating, I guess, is the word for projects that would actual restore acreage versus the whole project area. But on the other hand, what's the treatment of some of these projects in that regard to the ecological benefit beyond the acres of restored lands? How is that accounted for?
It's not right now. I mean, that's the bald answer. That's not thinking about wildlife corridors and connectivity and island biogeography. That might be a useful question to look at in this, trying to understand that within this annual report, where those habitats are connected to larger habitats. And we can argue both sides of the situation. It's important to have green space in multiple locations, and it's important to build out those large spaces for the mega mammals to be able to thrive, and our megafauna to be able to thrive. Go ahead, Marcus.
I'll add on to that too as well. I think what you're getting at, Brandon, is kind of this idea of cumulative effects of restoration projects. So like, does the sum of projects have an added value greater than the individual sum of any individual project? And that's a question that I think is very active right now in the restoration research community, and I don't think there's a good handle on what that means, but I know that people are talking about it and thinking about it, and it goes a lot towards planning of where you put these projects. It might be better to clump them all close together because there could be an additive benefit of putting them all in one spot versus isolated from each other. Talking about corridors or island biogeography type stuff that Gary's talking about. But I guess my point is people are thinking about this and there's not a simple answer, and we haven't really delved into that too much for this approach. But I think it's just something that we as restoration practitioners need to think about.
Yeah, I agree, and certainly you're right. There is no easy answer. I guess just the way the conversation was going with, making sure we're not accounting, being very accurate in the accounting for some of this restoration, which is a completely valid point, but just maybe taking a little broader perspective on that to recognize, the benefits don't essentially line up with those boundaries as well.
It's a good point. Yeah, it's a good point. I think in prior iterations of our comprehensive management plan, we've identified research priorities centered around ecological function and restoring for the benefit of ecological function, but we haven't really made much headway or described our targets and goals towards a functional goal for the future in terms of habitat, ecosystem services, or even diversity. So that might be something as we go through an interim update of our management plan to identify as a new research priority in relation to our established goals from the 2020 Habitat Master Plan update, and something that we can direct resources towards in the future to aid in the identification of appropriate function or biodiversity targets for the estuary.
Well, thank you for that discussion.
There's a Damon Moore had commented on the chat. Damon, I don't know if you wanted to chime in, or I could just read it for you.
No, I can chime in. As I've worked on the other side of that as far as the partner providing the reports to Tampa Bay and Sarasota Bay, working in Manatee County for a while, and we're had been a pretty active partner in a lot of those things. So when we get the annual request, and for Manatee County, it included Charlotte Harbor as well. So we get hit with all 3 estuary programs at the same time, and they want you to compile, all these data on every project, every restoration project, and that you've done over that past year. So I just as this discussion was happening, I was thinking if we had basically, instead of this sending out the spreadsheet with the instructions has been done in years past, if you built this into this kind of visual portal that all this really exciting stuff I'm seeing come up now, and then have this basically for lack of a better term allow us to spoon feed it back in a more less frequent time frame. I think you would get more, and then you would also you would probably capture more smaller projects that might not even make the list when we're talking about, oh, okay, I gotta report all this stuff back to the estuary program. So you may be missing some smaller community-based things where if you're asking for it more frequently, you could you'd pick those things up too, which I think over time, especially if we're talking about a 10-year time frame, cumulatively those would add up to something worthwhile. So just some thoughts there. The other thing too, as far as I know, spatial is difficult for a lot of the county partners who don't necessarily have a GIS team, and they're working on a shoestring just trying to do everything to get these projects done. I remember at some point when Stephanie Powers was at the district, she would send me this thing, and I would basically have to kind of draw in by hand a polygon of where these different types of restoration were going on. So I think that might be a good way to kind of get that, and then as you got that, say, hey, while it's still fresh and where they are on the files, send us a copy of those CAD files, or if you have the shape files on hand, get them over, but so they don't get 8 months out and somebody busy on another project. I think keeping it fresh is probably going to be helpful.
That's an interesting idea. Just sort of essentially leave a portal open year round where people could input their data.
And I think a pleasant reminder every once in a while, and I think I also mentioned in that comment, it would be really cool to be able to see that and know oh, so Hillsborough County's, they're kicking butt, they're doing something like that. And you know what I mean? It would motivate those kind of hey, look, other counties are doing that. And I mean, I could bring that up to leadership in these different organizations. And
is that all it takes to get restoration done?
People are inherently competitive. I really, it's
a friendly competition.
That's right.
Is true. Oh, too funny. Right. That's interesting though, Damon, that you brought up Stephanie and you guys having issues with the GIS and stuff like that. I know a lot of times often we were just accepting final construction plans and comparing it to as-builts, and that is usually required for all of our projects. And from there, we were able to, incorporate that, georeference it and turn it into spatial data. That's what was done for a lot of the old projects that we had to go back and look at. So, maybe that's something that we can look at, helping municipalities and things with, in order to be able to look at it, all these projects spatially.
Yeah, I think it would be a good idea to increase the frequency of the ask, though. I think that would help it keep it fresh in everybody's mind too.
I agree. No, that's a good idea. Thank you.
Okay. I'll just go ahead and pop through my last few slides to make sure that Ryan has enough time for his work. And these are just some examples of the projects that were provided to us this year during the restoration report. And I'll share that the pictures I have are requested during the process, and the ones that I have are most of the projects that I've received. So if you want to see your project up here next year, go ahead and send me some photographs. I'd really appreciate it. So Whiskey Stump up by the Schultz Preserve, Tampa Bay Watch partnered with the Audubon Society as a funding agency to put in some of their oyster balls around the shoreline of this eroding island. Hopefully over the next several years, we'll see some good oyster accumulation. And that leads right into Ryan's talk. It's part of the project. Eulalie Springs, this is one of our the enhancements that was reported on by Ecosphere. This year there was, I believe, funding from U.S. Fish and Wildlife Service, City of Tampa, and FWC for this component. I mean, there are multiple partners, SwiftMud and others, for the overall project that was completed several years ago. But this was erosion. They shored up the bank, did some earthwork, and then put a little seepable retaining wall in to help prevent future erosion on the project. In Copeland Park, this was a restore project that was partially funded through estuary program restore funds that we received several years ago. City of Tampa was the lead. This is a park in an underserved part of the city of Tampa. The little pond itself is probably about 5 acres. It was completely overgrown with all the exotics we know and love. They did some herbiciding. They did some digging out of the pond. And then now at least the Muscovy ducks and once in a while a wading bird are really enjoying those. And we're actually helping out on the monitoring side of this one. MacDill Air Force Base, they're always doing something at MacDill, whether that's with Tampa Bay Watch and the living shorelines around the southeast side, or Ecosphere and others doing ditch fill, mangrove ditch filling, and lots of maintenance work. They're out there roller chopping, doing exotic burns, and then letting the native vegetation come back in. And this is another one of the enhancement examples. And then Sezen wetlands out in the city of Lakeland. These are some old phosphate borrow pits that have been converted back to freshwater wetlands, primarily the non-forested freshwater wetlands. And they did some contouring. They had a lot of volunteers out there that helped with the planting. And the third picture on the right is showing the recent results of that. So there's different projects going from the subtidal to the uplands into the freshwater wetlands. And so as a quick wrap up, there were about 810 acres reported as restored in fiscal year 2021. We do recognize that there are probably some habitats that need some focus. Our low salinity salt marshes are up front and center, the oysters, the living shorelines, some other work. This data will be updating the Water Atlas restoration page probably sometime in January, and it'll have multiple information such as a brief project description, project name, when it was completed, cost, major partners, and this is all on in an interactive map, so you can zoom in and out and get that competition that Damon was talking about, find out who's been doing what recently. And it'll also have a downloadable Excel spreadsheet with all this information on it. And again, hopefully we'll be talking to you over probably the next couple of meetings about the creation of a user-friendly annual report that we can wrap all of this, the habitat restoration and LULC and seagrass data into something to help us better understand on a more comprehensive level how we're doing towards the implementation of the Habitat Master Plan. And this is just, thank you to all of you, all of our partners who are doing this habitat restoration and letting us know the great jobs that you are doing. We're here gathering this up, but you are doing the work, and that's greatly appreciated. So thank you, and I'll be glad to take any more questions at this time. And then seeing none, I'll go ahead and turn it over to Ryan.
All right, are you guys seeing that presentation now?
Yes.
Yes, we are.
And it's not presenter mode, it's the actual slideshow?
It appears that way, yes.
Okay, good. We're all seeing the same thing. Okay, so, and I guess I could turn my camera on. That would help. Okay. Thanks for inviting me to give this presentation. This is work that we've been doing the last couple of years in association with the Estuary Program and Tampa Bay Watch, and doing some monitoring on restored reefs in the bay. And this is work that was conducted largely by my lab. If any of you saw Scott Adams present this at the recent SURF meeting, a lot of this is very similar to his talk from SURF. But just a quick background about historical abundance of oysters in Tampa Bay. In the 1800s, Tampa Bay supported a robust oyster fishery and over 800 hectares, and we know that's not the case today. By the 1970s, we were down to basically about 100 hectares, and the losses, the big losses, were due to harvesting, dredging, shell mining, and such. But this isn't really a recent problem. As early as the late 1800s, the decline in oyster population was already apparent and enough to be reported on in this Smelt 1897 reference. Since the focus of this group is restoration, that really didn't start on a large scale in Tampa Bay until the early 2000s. So we have a few decades now of oyster restoration projects going on, but more and more are coming online, and you all saw the targets that Gary talked about earlier. So, okay. Sorry, I've got like 3 different screens here, so I'm trying to figure out which one is the right one. The rationale behind the project was that the 2017 CCMP update identified a need for long-term restoration or long-term monitoring on restoration projects. And so our goal, this was sort of an opportunity to do just that. And unfortunately, it's not long-term restoration necessarily, but really setting the baseline for long-term restoration and provide a systematic method to monitor oyster restoration sites and compare them to what's going on in natural reefs in Tampa Bay. So that was sort of the overarching goal, and then hopefully this lays the groundwork for future long-term monitoring events. We examined a few things with that goal in mind, and one of the things we wanted to know about was the type of substrate, and the three major substrates that we compared were mesh shell bags, oyster reef balls, or reef domes, as some of you may know them, and then loose shell that was placed to create reefs, and then compare that to natural oyster reefs as sort of a fourth substrate. But these were the three main created reef substrates that we used, or that we examined. We also were interested in characteristics of the site, and you can see this is the south end of Fantasy Island in Hillsborough Bay, and you can see that there are a number of reefs, constructed reefs here, and some of them are made out of bags, some of them are made out of oyster reef balls, some of them are yeah, there's some natural reef on the other side area. And so, you know, just looking at site characteristics and the elevation of sites, the orientation or the exposure to waves, the actual dimensions of the constructed reef were some things that we examined. And then this is a diagram showing the same. This is now the southwest side of Fantasy Island, and this is one of the Tampa Bay Watch diagrams, just showing the different ages of some of the constructed reefs at that site. And there are, in many cases, reefs of different ages co-occurring in the same general location, but that doesn't necessarily mean that oyster growth is the same on all of those reefs. So we also examined the age of construction, and for our purposes, we divided the reefs that we monitored into three age classes based on the years of construction, and we monitored reefs. The oldest reefs we monitored were constructed in 2006, and so we categorized the ones between 2006 and 2008 as old reefs, the ones that were built between 2015 and 2016 as intermediate aged reefs. And then we also were monitoring reefs that were basically just constructed 2018 and 2019, and those are what we called young reefs. So the approach was that we monitored for a 2-year period from March 2019 to March 2021. And for the younger reefs, we monitored those twice a year, and all other reefs were monitored once per year. And largely it was a quadrant-based approach. I'll show a slide that has some methods on it, or just some photos from the field of these methods shortly. But it was a quadrant-based approach for oyster density, relative percent live versus dead oyster, shell height, predator density, and really the only predators that we quantified were gastropod abundance. But so we used protocols that have been employed by our molluscan fisheries group at FWC to do monitoring in the past. So we basically used their methods in most of the cases. We also wanted to know a little bit about spat availability and if there was, you know, the potential for these things to even recruit new oysters. And so during the basically spring through the fall, April to October every year, we deployed spat trees and recovered them monthly, and then put out new spat trees at the same time we recovered. So we have a monthly database for spat settlement at these sites for the 2 years of the project as well. And along with actually counting the oysters and the spat, we also, again, some of those other characteristics we were interested in, we did reef elevations using RTK GPS, water quality, temperature, salinity, pH, dissolved oxygen, and then rugosity measurements using a chain method. And the sites that we worked in largely were centered around Hillsborough Bay, but then we also worked down in Perico Preserve down in Manatee County. But most of our sites were in Hillsborough Bay. And we had several reef types, again, loose shell, shell bags, oyster reef balls, and we also had some natural reef sites in the Kitchen and off of the port of Tampa. This is that slide I promised of just some of our field photos, and just showing the one at the top left is sort of reflective of everything that was going on. You can see Scott in the background doing the RTK, or setting up the RTK to survey. And we've got Savannah and Sam in the foreground, and they are actually counting the oysters there. The quadrat-based approach worked well, except when we had oyster reef balls, and that's very hard to fit those in a quadrat. So we had to come up with a slightly different strategy, and we counted, we basically divided the reef ball up into a circular portion and counted 165 degree pie slice. And we also measured the height of the reef balls, from the sediment base to the top of the reef ball, to look at burial and things like that as well. This is a photo of our spat tree at the top right. I'm not sure if you can actually see the mouse or the pointer. Since I've got a bunch of different screens, I'm not sure what you're seeing right now. But at the top right is just a photo of one of our spat trees in front of one of these that looks like mesh bags for the reef. And then just to give you an idea of the complexity, and not all of these sites had all three reef types present, but especially in the case of Fantasy Island, we did have, it was quite a complex set of constructed reefs and different reef ages, and we basically had everything at Fantasy Island or very nearby it. To just dive right into the results, because I know we are running out of time. Looking at the type of substrate on these reefs and comparing the oyster reef balls to the shell bags, and then looking at the ages of each one. The oyster bags had higher densities of oysters than the oyster reef balls, but there was really no difference in shell height. So if you're looking at the graph on the right, the oyster densities are the bars and the shell heights are the dots. And there was no significant difference between shell height on the bags versus the oyster reef balls, but there were significant differences between shell bags and oyster reef balls in terms of oyster density. So higher densities on the oyster bags, and I'll talk about the age structure in a moment. So, but you can already probably see that the younger reefs were always supporting higher densities as well. So I've given away that punchline, but I'll talk about that on an upcoming slide. There was also a generally positive trending relationship between elevation and oyster density, especially with the shell bags and the oyster reef balls, but there really wasn't as much of a trend with the loose shell reefs or the natural reefs. And you can see that in the plot at the right, and you can see the strong positive trend with both shell bags and oyster reef balls. And it didn't really seem to matter much on the age classes there. All age classes showed a very similar relationship between elevation and oyster density, whereas the relationship was not nearly as strong with loose shell or natural reefs. And of course, there's no way to tell. We did not split the natural reefs up into age classes because there's not much of a good way to tell with that. We also did some modeling using the data and wanted to investigate this a little bit better. And it seems, again, there's not much of a relationship between elevation and natural reefs, and slightly higher elevations support slightly higher densities on natural reefs, but there's a strong indication with the modeling work that both for shell bags and oyster reefs, the optimal placement may actually be in the higher elevations within the tidal frame. And some of that has to do with things like predator density, where there's a lower density of predators, slightly higher in the tidal range, and things like that. Was one of the things that our data showed, was that a higher density of predators at lower elevations and fewer predators at higher elevations. So that may be one of the lessons learned for both shell bag and oyster reef ball placement, is that in a lot of these restoration projects, you talk about the importance of getting the elevation right, but it may be important to install these things slightly higher in the tidal range, and that actually helps with sea level rise planning as well, because if you're already installing them higher in the tidal range, as sea level rises, they will become more intertidal or lower, subtidal restored reefs potentially. Some other site characteristics, this is what I was alluding to. There was increased predator density at lower elevations. This was most noticeable on the oyster reef balls, not as strong of a trend with the shell bags, the loose shell, or the natural reefs, but there was still some, a bit of a trend where you had higher densities of predators at lower elevations. And this is just, during low tide, there's less predation because the predators stay in the submerged portion of the reef, which is at the lower elevation. And then the third parameter we looked at was the age of construction. And again, I've already kind of given this away, but the youngest sites had the highest shell density, but again, this was no significant difference in shell height over time. And so again, you're looking at densities with the bars, and the dots represent the shell height. So when we look at separate these out by age classes, there's no significant difference between shell height or shell length, but there are higher densities of oysters on the younger reefs. Some of this may have to do with, you can barely see the top of the reef sticking out in the image to the upper right, and some of this may have to do with the older reefs are accumulating sediment, and some are being buried almost completely over time, and that's obviously going to support a lower density of live oysters. So the story so far is that there is probably an optimal growth zone where you're balancing between subaerial exposure, which has less, fewer predators. You may be getting higher density and slightly smaller oysters, but so it kind of depends on what your restoration goals or targets are. Do you want harvestable oysters with large shell heights, which usually isn't the point of restoration, but it really depends. Or do you just want dense clusters of oysters and a well-functioning reef? But there really is this optimal growth zone somewhere between the highest elevations and the lower elevation. So that blue area would be your, I guess, your Goldilocks zone for the oyster restoration. This is the spat data that we're looking at here, and this is just a plot basically of every site that we had for the months of April through October, and you're looking at 2019 are the filled blue circles and 2020 are the open circles. And what was kind of surprising, the systems certainly aren't spat limited. There are spat at all sites, pretty much throughout the summer, but there are some months that have no spat, and then there are some months that have a lot of spat. And even most of our sites were in Hillsborough Bay, even within one small bay segment. If you look at the spatial distribution of the patterns, or even at the two McDill sites, or the three McDill sites, sorry, which are panels C, D, and E, larger abundances of spat in different months relatively. And so there's actually high variability, both spatially and temporally. And unfortunately, sorry to, Damon, who's not there anymore, but Perico really didn't have, that was the only site that really may be spat limited. We also were looking at net elevation change over the 2-year period. I mentioned burial, and this is just a time series of elevation change with positive gains in elevation in green and losses in elevation in red. And the top panel there is McDill Air Force Base, and the bottom panel that just came up is 2D Island. And you can see in some cases that there was, you can see the time frames. This is 3 different time steps from April 2019 through the end of the elevation surveys in December of 2020. And there are shorter scale differences where you lost sediment, then there's a gain of sediment in the next few months. This may have to do with Tropical Storm Ada, which we also investigated, but I'm not talking about here specifically. But we do have some information on elevation changes specifically associated with Ada, if anyone is interested in those. But you know, the main story is that you should be seeing elevation gains behind the reef, and you know, in some cases, you're not always getting those net elevation gains, and there still are elevation losses in front of the reef, which is where you might expect them in some cases. But the shoreline, you know, in the case of McDill, the reef is meant to attenuate some wave energy and slow down shoreline erosion, and unfortunately, at the end we were still seeing losses. So we may need a longer time frame to understand the elevation dynamics in more detail, but we do have some information on short-term changes in net elevation. And this is a summary slide that shows mean site elevation change over the whole project, and many of the sites actually did lose elevation. This scale is in meters. So you're only talking about a few centimeters elevation, but that makes a pretty big difference for these systems, especially as the ocean level is coming up. But we did have some areas that also were gaining in elevation, including most of the McDill sites, which is a good thing as well. And the natural reefs all gained elevation. So I've got 2 minutes left before the meeting, before you guys kick me out. So I will get to the summary and recommendations. But just to recap, shell bags hosted the higher oyster density than other reef types. There was a positive relationship between oyster density and elevation, especially on the shell bags and the oyster reef balls. We had increased predator density at lower elevations, so the optimal zone may be to install these things might be at higher elevations within the tidal frame. The younger reefs hosted the highest density of live oysters, but there was really no significant difference in the shell height across any of these parameters that we looked at. And the spat is not limited, but it is highly variable in space and time, which may be a consideration for restoration, or at least getting oysters to settle when you want them to settle. So this bullet point to the upper right, basically our optimal elevation zone here is between minus 0.2 meters to plus 2 meters NAVD 88 elevations, and that's because they exhibited lower predator density, decreased sediment burial, and higher density of live oysters. So that would be a recommendation for installing at those target elevations. And again, the lower elevation reef supported the largest oysters. I didn't really show elevation versus shell length, but the shell length was larger, larger at lower elevations. And it really, you know, some of the biggest recommendations are that you need to carefully consider restoration priorities and what questions you're trying to answer when both monitoring and installing these reefs. And with that, I will thank our partners in all of this who weren't already identified on the title page, and of course our funders. And it is exactly 3:30, so if anyone is still left, I will take some questions if there's time for that.
Hey Ryan, this is Tom Rees calling, talking. I just had one question for you. Were you able to determine whether these oysters were alive or dead at any of these sites?
Yeah, we didn't show that data, but we did count both live oyster total number of live oysters and total number of dead oysters, and we did actually do excavations within a small plot to determine that. And I don't have those numbers in front of me, but if you're interested, just shoot me an email and I can get you that information. But yes, we did do that.
Okay, yes, thank you. I will send you an email. Thanks so much.
Ryan, can you hear me?
Yeah, I can hear you.
Hey, Doug Robison here. Just a quick question, because you did these all on one site, the study at one site, as I understand it. So you weren't able to evaluate salinity in any way, right?
We did measure salinity, but we didn't. Yeah, I mean, it was all in Hillsborough Bay,
Right.
except for the one location down at Perico. And yeah, there weren't any, you know, salinity was really a non-story. We didn't look at this across like a very strong salinity gradient. And we didn't do it long enough to see any large scale changes in salinity due to saltwater intrusion or anything like that.
Are you going to publish?
We didn't have the temporal density of sampling to like sample after a rain event or something when there's, you know, there might be a sort of pulse of fresh water.
Are you going to publish these results, or have you?
We are working on this. There is a report. I don't know if Gary's posted it, but we actually caught a few mistakes, and we're in the process of revising the report on this. And so that will be available on the estuary program site if the uncorrected one isn't already. And we are actually working on a manuscript to go along with that to get submitted at some point. But it's been a slow process.
It is not up there yet. I was waiting for the corrected version. Hint, hint.
Yeah, we are working on it. Unfortunately, this was sort of Scott's baby, and unfortunately, Scott left us last month, and so we're slowly picking up those pieces, and it's created a few delays. But yes, we do have a report pretty much ready to go, yeah, we may even get it to Gary this week yet. No promises, but possibly.
Good stuff. Thanks.
All right. Thank you very much, Ryan. Does anybody have anything real quick? We're a little over. Going once, going twice. Okay. Well, thank you, everybody. I don't know if Gary or Doug want to chime in and say anything. I just have one little quick add here. Our next meeting looks like we're scheduled tentatively for April 6th. And if anybody has any topics or any presentations, lessons learned that they would like to share, please contact Gary, myself, or Doug. And then just one little interesting of note, apparently Gaillardia is no longer considered a native flower. So I don't know if that breaks your heart as much as it does mine. So, you know, I guess you can still plant it in your yard as Florida friendly, but if you're doing any upland restorations, it's supposed to no longer be considered native. So take that what you will. And Gary, I'll let you go ahead and close out. Thanks, everybody.
Again, thank you all for your attendance. Appreciate the input. Appreciate the work you're doing. Have a happy holidays.
Thanks, Gary. I'll talk to you later.